We're going to go ahead and continue our lesson. So now we go to part D, which is x to the 6 minus 64. So when we look at this one, you'll notice that these are both squares and cubes. So because they're both squares and cubes, we'll take care of them as a square first. So as a square, you're looking for a squared and b squared, which means you're looking for the square roots. So to find a, instead of taking the cube root, we'll take the square root of x to the 6, which is x to the 3rd. And for b, we'll do the same thing. We'll take the square root of 64, which is 8. So what happens is this part factors to be x to the 3rd minus 8 times x to the 3rd plus 8, which actually makes it a difference of 2 cubes and a sum of 2 cubes. So because of that, we're going to have to find a and b again. Fortunately for both of these, a and b are going to be the same. So a will be the cube root of x to the 3rd, which is x, and b will be the cube root of 8. The cube root of 8 is 2. So now we'll put it into the factoring pattern. So the first one will be a difference of 2 cubes, and the second one will be a sum of 2 cubes. So as a difference of 2 cubes, it's a minus b, so x minus 2, times a squared. I'll go ahead and just write the square out. That's a squared, plus a times b, which is x times 2. I'll just write it as 2x, plus b squared, which is 2 squared. I'm just going to write it as 4. So that is the difference of 2 cubes half. Then we need the sum of 2 cubes half, which is the same numbers, just different signs. So a to the 3rd plus b to the 3rd says a plus b, so x plus 2, times a squared, which is x squared, minus ab, which is 2x, plus b squared, which is 4. With this, we have finished part D. Moving on to part E. Part E says we are looking at 18x to the 4th minus 50y squared. When we look at these again, it's neither a perfect square or a perfect cube like in problem number B. So we have to look for GCF. So let's take out that GCF. Hopefully you'll notice that the GCF again is 2. So we're going to take out the 2. Divide out the 2, we're left with 9x to the 4th minus 25y squared. So when we look at this problem, you'll notice that it's x to the 4th and y squareds, so they are squares, not cubes. So to find a and b, we'll take the square root. So it's the square root of 9x to the 4th, which is 3x squared. And for b, it's the square root of 25y squared, which is 5y. So using its factoring pattern, it becomes 3x squared minus 5y and 3x squared plus 5y. We do need to make sure that we bring down the 2, though, that we factored from the beginning. Our last problem will be problem F. Problem F says to factor negative 2p to the 5th plus 12p to the 3rd minus 18p. So this one's neither a difference of squares or a difference of cubes because there are 3 terms. So the 3-term one is actually going to be factoring a perfect square trinomial. But you'll notice that none of these looks like perfect squares, and again, that's because they do have a GCF. So the GCF will be 2 and p, but since I don't want my first term to be negative, I'll factor out the negative as well. So I'll take out negative 2p. So when you're factoring, you're dividing. So when I divide out the negative 2p, I'm left with a positive p to the 4th, a negative 6p squared, and a positive 9, which makes this a perfect square trinomial. So for our perfect square trinomial, again, we'll still have to find a and b. So a will be the square root of that first term, which is the square root of p to the 4th, which is p squared. And b will be the square root of the last term, which is the square root of 9. The square root of 9 is 3. And just to make sure that it's a perfect square trinomial, if you multiply these two together and then times it by 2, it should equal the number on the inside, which it does. So it is a perfect square trinomial. So because it's a perfect square trinomial, you follow its pattern, which is just to take the a term, which is p squared. There's a minus in the middle, so it would be minus, and then the b, which is 3, and then put a square. But don't forget to put the negative 2p that you factored from the beginning. And that's problem F and the end of our lesson.